what's up? All right, so today we're going to talk about some more Pythagorean theorem. We did Pythagorean theorem problems, just regular ones with triangles. We did them on a coordinate plane, and now we're going to look at some just some interesting ones that are a little bit different. Okay, so the first one is when you have a rectangle and a line going through it. And they may say the length of the rectangle is 12 meters, the height is 8 meters, how long is the diagonal, okay? Well, when we see a problem like this is just a regular Pythagorean theorem problem. All you have to do is erase half of this rectangle. So if I just did this and took some of this out, we can see that we have a right triangle, and here's our right angle, right? Okay, so just because this rest of this rectangle is here, doesn't mean that you don't still have a right triangle here. Okay, so to solve this, be really simple. 12 squared plus 8 squared equals c squared, right? A, B, and C, right? Now they might use different letters like x, but we know that these are the two legs, and this is the hypotenuse, right? The two short sides and the long side. And the two short sides always touch the 90. So even though it's a rectangle, it doesn't make it any different. It's still this is a rectangle, but there's still a right triangle inside there. You still have this, okay? So you just need to focus on that and kind of pick it apart and look at it. So nothing too hard there. The other thing is direction problems. So what I'm going to draw up here is called a compass rose. And they have these on maps. And this is north, south, east, and west. All right? So a lot of times they may say you travel, or maybe you ran 12 miles north, and then you went 7 miles east, and then you took a shortcut home. And they may ask, how long is the shortcut? All right? So, when you see problems like this, all you have to do is draw a picture, all right? So we know north on a map is generally up, right? So 12 miles north, I just draw a line going north, going up, put a 12 by it. Then it says 7 miles east. Well, east is to the right on maps. So from that 12 miles up, this one's gonna be a little shorter because it's 7, right? I'm just guesstimating how long they are. So this is 7 miles. This is 12 miles. And then they said you took a shortcut home. That just means back to the beginning, right? Well, what do we have here? A right triangle, just like we had before, right? Here's your right angle. And then here's your shortcut, right? That's hypotenuse, the C. All right, so that's just gives you an idea of, you just have to actually draw a picture when you see things like this. So 12 squared plus 7 squared equals c squared, right? 144 plus 49 equals c squared. 295 equals c squared. Then we find the square root of that, right? To get rid of the squared. So, once again, calculators are your friend. Square root, because I don't know the square root of 295. Oh, it's 17.1 miles is how long your shortcut is, okay? So I just did the square root of 295, right? And you can see 17 is a little bigger than these two, right? So it makes sense. Got to make sure that it makes sense. All right. Well, this should have been 293. I messed it up a little bit. Either way, it's going to come out 17 point something. You got the idea. All right, sorry about that. Let's look at another one of these, because these come up a lot. We'll say we traveled 13 miles south, and then we went 4 miles east, and what's the shortcut home? Okay, so south is down, right? According to my compass rose here. So I go down, put 13 on it, and 4 miles east. A lot shorter, right? And bring it back. Right triangle, just like we had before. Do it the same way, all right? Okay. So simple problems like that. I think we've already done ones where they tell you the legs. I want you to find the missing side. So they gave you one leg, they gave you the hypotenuse, but they didn't give you the other leg. So I would say, remember it's a squared plus b squared equals c squared, right? Hypotenuse is always c. Do one of the legs is 5. And don't forget your squared there, very important. 5 times 5, and don't put 10. It's not 5 times 2, it's 5 times 5. 25. This isn't 26. It's 13 times 13, not 13 times 2. It's 169. Solve our equation, right? Draw your line. Subtract for 25. I get a squared, those cancel out, right? A squared equals 144. Then square root of 144 is 12, right? All right, so this is just one where they don't draw the picture, but they tell you the word. They tell you which ones are the legs and which one's the hypotenuse. You just plug them into your formula and solve it. All right, so that's it for today. More Pythagorean theorem problems, more uses for Pythagorean theorem. Oh, I got one more to show you. And I've seen this problem a lot on the OAA. You draw a tall building, and you have a ladder going up to the top of it. And they tell you that the building is like 24 feet tall. The distance from here to here is like 11 feet. And they want you to find how big is the ladder. What do we have here? We have a right triangle, right? And my building's a little crooked, but you get the idea. Here's your right angle, right? A squared plus b squared equals c squared, right? So you can pretend the rest of the building isn't there. And look, you got your right triangle. Here's your right angle right here. Like I said, I had the building leaning a little bit, but it should be straight up and down. So this is your A and B, and there's your C, okay? So more uses for Pythagorean theorem. At some point I'll tell you the story about Rick the plumber and how he used Pythagorean theorem to save hundreds of dollars. All right, so that's it. Take care and have a good day.